All right, let's look at calculating both average and instantaneous rate from our graph here. And so the key here is, well, first to understand, is it being created or destroyed? And what we see is the pressure is going down of the N2O5. And so we're going to call it destroyed. If it was going up in some sort, so you would see like a graph like that, it would be being created. So that's first question. Then it's going to ask both the instantaneous rate and the average rate at some time. And then this one is 900 seconds. Now, the best way to do this is to pull out our tool here, which is this big pencil we get. And I'm going to go to 900 seconds. If I click on that, I can then unclick here. It's going to give me a lot of important information. So I have now 900 seconds. What is the exact atmospheric, the exact pressure in atmospheres at 900 seconds? And then it draws this tangent line as well, which we're going to use. So the first thing we're going to do is find instantaneous rate, which we do with our tangent here. And so we're seeing at this instant, so the slope of the graph, we're drawing a tangent line. We can see how much pressure per second. So this is the pressure change per time. And so we're going to put that our change in pressure over our change in time, which is 2090 seconds. So we get atmospheres per second. So plug that in and we get 0.00933 atmospheres per second. We scroll down here, we get, it asks for 2 significant digits. So I'm going to go with 9.3 times 10 to the negative third. Now you do need units here. So I'm going to type in my atmospheres and then hit the fraction button and do atmospheres per second. So that's my instantaneous. What about average? So average, we're going to look at how much it's changed over those 900 seconds. So we're looking at this difference here. So we're going to go 23.647 minus 11.1032. And we get 12.5438, and that is per 900 seconds. So we get 0.0139, and again, it asks for 2 significant digits. So I'm going to say 1.4 times 10 to the negative 2. And again, atmospheres per second. So we got instantaneous rate using our tangent line, and we have our average rate using the change over the 900 seconds. Let's do a check. Looks good. So understanding those 2 types, using this pencil tool is important to get those exact values, and then pay attention to units and significant digits. Some might be molarity per second, for example. So you got to put that in when you put in your answer.